Lesson 1.6, we're going to look at solving compound inequalities and also absolute value inequalities. Some key terms here, and you can pause this if you need to write down the definitions. Compound inequality is two inequalities joined by the word and or by the word or. So it's an and or an or statement. The intersection is the graph of a compound inequality using the word and. So an and statement is an intersection. A union is the graph of a compound inequality using the word or an or statement. Like I said, pause it if you need to write down the definitions. We're going on to the first example here. We're going to look at solving a compound inequality that's an and statement. Now notice you don't see the word and written in there, but you kind of have three parts to this inequality right here. Okay? You've got 10 on the left, less than or equal to 3y minus 2, and then less than or equal to 19, which really says 10 is less than or equal to 3y minus 2, and 3y minus 2 is less than or equal to 19. What you need to do is solve for y in the middle. Okay, so you want to solve for the variable, which in this case is y, in the middle. You want to get the variable alone. So, how do we do that? Notice what I have right here. I have 3y minus 2. I have a multiplication and a subtraction in there, so I undo the subtraction of 2 first. So I want to add 2 to get rid of it right here. Now, you have three parts to this. You have a left, a middle, and a right, so you need to do the adding 2 in all three parts. We done undo it in the middle to get rid of it. Okay, so here's what I'm left with. 12 is less than or equal to 3y, which is less than or equal to 21 when I add 19 and 2. Now I need to undo and get y alone in the middle. I'm multiplying y by 3, so to undo that, I want to divide by 3 to cancel it out, which will leave me with y alone in the middle. So I have to divide by 3 over here, and I have to divide by 3 over here. So this is 7, and this is 4. So your solution is 4 is less than or equal to y, which is less than or equal to 7. We got y alone in the middle. Now to graph that, that means that 4 is less than or equal to y, and y is less than or equal to 7. So it's the numbers between 4 and 7, and we're going to include 4 and 7 because of the equal to part on the inequality. So we've got 4, we've got 7. They are going to be closed circles. Remember, if it has the equal to part on, they are closed circles, and we're graphing in between. So there's the numbers that would fit that. Okay, let's look at an or statement. An or statement, you're actually going to see the word or written in there. Okay, notice there's two parts. There's x plus 3 is less than 2. So here's one part. Okay, and then the other part is negative x is less than or equal to negative 4. And notice the word or in between. You solve each part. Solve each part of the or statement. And your final answer needs to be written with an or in the middle. So to solve here, I'm going to subtract 3. Okay, so x is less than or equal to negative 1, or, and you need to write the or in there, over here, or the right side of the or statement, I have negative 1 times x. It's a negative x, so I'm going to divide by negative 1 on both sides. Remember, switch the symbol when you divide by a negative, or multiply by a negative. Okay, so but you switch the direction of the inequality. So I have x, and I'm going to change the direction to greater than or equal to. Negative 4 divided by negative 1 is 4. So there's my solution. Okay, now how do I graph it? Well, you graph, this is a union, so it's going to be x is less than negative 1. So how do I think about graphing that part? Here's negative 1, less than means open circle, and the numbers to the left would be less than negative 1. Greater than or equal to 4, 4 is going to be to the right of negative 1, and greater than or equal to is going to be the numbers to the right of 4. So there's what that graph looks like. But if it's an or, you do any part that's graphed. Okay, if they happen to overlap, it would be any numbers that are graphed. And you might have some of those in your sign problems. Okay, now we're going to get into absolute value inequalities, and you need to use your help sheet, the bottom half of that. Top half is the equations, then we have the inequalities. And I'll pull that up here as I go through things. So, this one is a less than, okay, meaning the absolute value of something is less than some number, okay? So we have the absolute value of something. We're going to have expressions in there like we did with equations, is less than some number, okay? So absolute value of A is less than 4, okay? So if we pull up that sheet, the help sheet, and let's scroll down on it to the bottom, okay, so you can get yours out. So we're looking at the inequality part here on the bottom, okay? So here's what I'd have. I have the absolute value less than B, okay, the absolute value, I'm looking at this one, and B is a positive. Then this is what I write right here. Okay, notice B is the number on the right, so we have to, again, it's absolute value, so you got to look at the negative and the positive case. So A, or what's inside absolute value, goes in the middle, okay? The opposite of the number, okay, because that's a positive number over there, goes on the left, and the number itself goes on the right. So, again, this is what we're writing. If the absolute value of A is less than B, which is the scenario we have here, tells us we write this. You put the opposite of the number, and B is a positive. Remember, this was a positive number. Okay, we put the negative on the left, the positive on the right, and A goes in the middle, and it's in between the symbols, so we're getting smaller to bigger, left to right there. So that's kind of the rule we're following on that help sheet. Okay, so let's go ahead and do this. So here's my B, and A is actually A in this case, but sometimes you might have an expression like 2x plus 6. So you're going to put negative 4, or the opposite, because this is a positive number right here. 4 on the other side. Okay, symbols go this way, and the only thing we have in there right now is A. If you have like a 2x plus 4 in there, then you'd have to get the variable alone in the middle, solving like we did on that first compound inequality. This is already solved, so there's how you would write the solution. Now let's graph it. This is all numbers that go from negative 4 to positive 4. No equal to part on the symbol, so we're in between them. Okay, now we're going to look at the other one. And if you look at your help sheet, this is where we have the absolute value is greater than some number. So we're following that. Notice the number in this case is 4, so it's a positive. So let's pull up that help sheet, or get your help sheet out again. So I have absolute value, so it's either 1 or 2. Notice the absolute value side is bigger. And B is a positive, so we're following number 1 here. Okay? It's an OR statement. So there's what we write. A is greater than B, or A is less than negative B. Okay, so here's what we're going to write. Here's my A. Well, so here's what we have. A is greater than 4. Notice that's a positive. If that's the case, we write A is bigger than B, or A is less than the opposite, smaller than the negative of it, or greater than the positive. Those numbers would have absolute value bigger than 4. Okay, so if we write that, we're actually going to, this is A, this is B, so A is bigger than 4, or A is less than negative 4. Okay, now how do we graph that? So that would be the solution, because A is by itself. Again, if you have an expression inside there, then you have to solve each part of the OR, like we looked at earlier with solving the OR statement. Okay, this one, A is by itself on both parts of the OR. So A is bigger than 4 would be here, going that way, and less than negative 4, and going that way. So there's what that graph would look like. Okay, now we'll get into solving a multi-step absolute value inequality. So, if you look at this, This is the absolute value is greater than or equal to some number. Okay? So in this case, the A, like we did with equations, is the 3x minus 12. Okay, now we have an equal to part on this. That means when you follow those rules, you put the equal to part on your symbol. Okay? So if that's the case, it's A greater than. It follows the rule that we just did on the last example. Okay? So this tells us we have to do A is bigger than or equal to B, or smaller than or equal to the opposite of B. There's the OR statement that we're following. Okay, because the absolute value side is bigger. So A is 3x minus 12. So if I write this, my A is 3x minus 12. This is where we now have an expression inside there. Okay, greater than or equal to, and again, this is a positive number here, greater than or equal to 6, or A, which is 3x minus 12, is less than or equal to the opposite, or negative 6. Now notice, this is multi-step because we now have to solve for x in each part of the OR, kind of like we did earlier for the compound inequality. So I'm going to add 12 to each side. So 3x is greater than or equal to 18. Then I'm going to divide by 3. My next step, x is greater than or equal to 6. Now I have to do a similar thing over here. So we're going to add 12. We've got to solve this part of the OR statement. So 3x, that's gone, less than or equal to negative 6 plus 12 is 6. And we're going to divide by 3. Okay, so 3's cancel. Or, carry down the OR, and please write it with an OR. X is less than or equal to 2. There's my solved inequality. So now you graph each part of the OR statement. X is greater than or equal to 6 would be closed circle, and all numbers bigger. Bigger goes to the right. Or x is less than or equal to 2. So 2 is going to be over here. And we're going to go that way.